Hi everyone, welcome back. So today's topic is going to be on dynamic memory allocation. Before getting into the concept, let me tell why we need dynamic memory allocation. Let me take an example. Int a of 10. This is an array declaration, which means I need to store 10 numbers of integer data type. So before storing the value, we have to allocate memory for the array. So we will have a 10 blocks 1, 2, 3, 4, 5, 6, 7, 8, 9, starting from index a of 0, a of 1, a of 2, so on up to a of 9. Okay. Now array variable a can store to maximum of 10 elements. Now suppose instead of 10, if I would like to store at this moment, I would like to store only 3 values 10, 20 and 30. Only 3 blocks of data are reserved here, stored here, but the remaining reserved memory I'm not using at present, which means it goes as memory wastage. There is memory wastage at this instance. Next time when I'm running, I might use a different different blocks of memory in order to store the value. It might not be exactly 10 values, it might be less than 10 values. Fine. So this type of memory allocation is done during compile time. It is done during compile time. But in order to avoid the wastage of memory, whatever the actual data we need, only that much of data, to store that much of data, we can allocate memory during runtime. Okay, this allocation of memory during runtime is called as dynamic memory allocation. So allocating memory during runtime is called as dynamic memory allocation. So we have 4 different types of inbuilt functions. One is malloc, calloc, realloc, and fourth one free. So we have 4 built-in dynamic memory allocations. Okay, so let me first, today's session will be on malloc. Dynamic memory allocation using malloc. Fine. So malloc is a built-in function which is declared in the header file. Which header file? stdlib.h. So when I'm using malloc, calloc, realloc or free, then I have to include the header file stdlib.h. stdio.h. stdio.h is the header file which is mainly used for IO instructions, input output instructions like printf and scanf. When I'm using printf and scanf, then I have to include the header file stdio.h. Similarly, when we are allocating memory dynamically, that time I'll be using either of the memory allocation function, malloc, calloc, realloc or free. Okay, in such case, these functions are declared in the header file stdlib.h. So I have to use stdlib.h. Fine. This is the first point. Second point, malloc function stands for memory allocation. So what is the abbreviation of malloc? Memory allocation. The next one, it is used to dynamically allocate. Note this point, it is mainly used to dynamically allocate a single large block of contiguous memory, which means what is the actual memory space I need? The entire memory space has been stored as a single block of continuous memory. That's why it's called contiguous memory. This is very important. This is the actual difference between malloc and calloc. So how malloc allocates memory? As a single large block of contiguous memory. What is the syntax? The syntax is void star malloc size underscore t and size. So let me teach you each and every keyword here. So malloc, coming to malloc is an inbuilt function which is stored in the library stdlib.h. It allocates memory block according to the size specified in the heap. So what is heap? It is a free pool of memory available. Heap is nothing but free pool of memory available. Okay, so out of the free pool of memory, whatever size we specify, based on that size, malloc will allocate the memory as a single block of contiguous memory. Understood? So the size that we specify here, this is the actual syntax of malloc. Okay, so malloc, the size that we specify, whatever is the size from the heap, it will allocate the memory space as a single large block. Note, what is the note? On success of memory allocation, on successfully allocating memory, it returns a void pointer. Void pointer is returned where the first byte of the memory allocated is pointed by the pointer. Understood? So on successful return, it returns a void pointer where it points to the first byte of the allocated memory. That I'll teach you in the coming example. Otherwise, if the memory is not allocated, what is the return value? Null is the return value. On successful allocation of memory, void pointer will be returned, that is void star. It is the default return value of malloc. What is the default return value of malloc? It is void star, void pointer. Okay, malloc, and malloc is the memory function, and size is the size of the block, memory block that we need to create as a single block. But what is size underscore t? Size underscore t, it specifies largest unsigned integer, which is also defined. Size underscore t specifies the largest unsigned integer, which is also defined in the header file stdlib.h. Okay, so what is this? Now we have size underscore t of size. The size that we specify should be an unsigned integer, which means the size cannot be a negative value, right? So it should be all positive values. So size underscore t specifies an unsigned integer, largest unsigned integer. Okay, this is also kept in the header file stdlib.h. Now see the example here. If this is the free pool of memory that I have, and the size that I specify, it is one single large block, will be allocated using malloc function, and the default return value will be the void pointer by name ptr. Ptr is the void pointer on successful allocation of the memory. Okay, now this is the overall explanation of dynamic memory allocation using malloc. But coming here, what is void pointer? Why void pointer? Why I have to specify void pointer? If you see the syntax here, it is void star. Why void star? Fine. So malloc, it doesn't have any idea about what it is pointing to, which means what value should be stored inside the memory allocation. We allocate the memory, but what type of data it should be stored, malloc is not at all worried about that. It only allocates memory, but it doesn't have any idea about what the data will be stored in the memory allocation. That's why void pointer is one of the pointer that points to any type of data. Okay, why void pointer? It is a type of pointer that points to any type of data. Any type of data can be stored once the memory is allocated using malloc. Fine. Later, the user can typecast to whatever type of data he wants. Okay, so the void pointer can be typecasted. Now you understood why void pointer? Because after memory allocation, after single block of memory, malloc is not worried about what type of data should be stored within the memory allocation. So it accepts any type of data. That's why it is void pointer. Fine. Now for example, see the example here. Int star ptr, it is a void pointer name, star ptr is equal to int star. This is the typecasted data type, malloc of 4. Now what is this 4? 4 is the number of bytes that needs to be reserved. So we need 4 bytes of memory. malloc will allocate 4 bytes of memory in the heap, and the address of the first byte after allocation, the address of the first byte, suppose this is 4 bytes of memory, the address of the first byte will be pointed to by the ptr variable, will be stored in the pointer variable. So the address is stored in the pointer variable. Understood? So what is int star? After successful allocation of memory, malloc will return void pointer, whereas void pointer in turn will typecast it to int pointer, where int pointer will store all integer values within the memory allocation. Got it? So this is typecasting. Now let's see an example here, an example program. Fine. So what is the first header file? stdio.h. Second header file stdlib.h. Fine. Within main function we have declared two variables, int n and I. First, enter number of integers. Scanf %d address of n, which means since it is an integer value, the format specifier is %d. And now if I write n value as 3, which means 3 integer values I need to store, int star ptr is equal to int star malloc n into size of int. Now what is size of int? We might not know what exactly the system, the processor is, whether size of integer operator for integer will be either 2 or 4. Okay, so we take size of int. Suppose if it is 4, then it is 3 into 4. So 12 bytes of memory is required in order to store 3 integer values. You understood? You're clear? So now if suppose n is equal to 3, I want to store 3 integer values. For 3 integer values, what is the memory size that is required? It is 3 into size of int. If it is 2 bytes, then it is 3 into 2, 6 bytes of memory will be allocated. Or if it is 4, it will be 3 into 4, 12 bytes of memory will be allocated. Fine. And once memory is reserved, the return value of malloc will be void pointer, and it is typecasted with int star, which means the value stored within the memory allocation will be of type integer, and the first byte after memory allocation will be stored at ptr. ptr will point to the first byte of the memory allocation. Now see the condition here. I hope you understood these lines. Now see this condition. If ptr is equal to null, which means if the return value of ptr is null, it's not void pointer, then what does it mean? Memory is not allocated, so it exits with value 1. Okay, this is the condition if memory is not allocated. If not, what happens? For I is equal to 0, initially I value is 0, I less than n, so trace 1, I value is equal to 0. 0 is less than, what is n value? 3. It enters. Printf enter an integer. Suppose I enter 10. Where is it stored? Scanf %d ptr plus I. For example, if the memory, okay, ptr is pointing to the first address. Suppose if the address is 1000, ptr is pointing at address 1000. Fine. The value that I am reading is 10. Where I am storing 10? When I value is equal to 0. So the value 10, where it is stored? ptr plus I. What is ptr? It is the address. 1000 plus what is I value? 0. 1000 plus 0 will be at address 1000. I will store 10. Got it? Then for the second iteration, trace 2. What is I value? I is equal to 1. 1 is less than 3. Now if I enter 20, where is the 20 stored? It will come inside. 20 will be read here with %d. ptr plus I. What is current value of ptr? Address pointed by ptr. It is 1000. 1000 plus 1. Suppose if it is 4 bytes. Size of int for this particular system is 4 bytes. Then it will be 1000 plus 4. So at address 1004, 20 will be stored. You got it? So 1000, when I is equal to 0, it will be address 1000 plus 0. At address 1010 will be stored. When I is equal to 1, it will be ptr plus 1 into 4. ptr plus 1 into, if size of integer is 4, then that is nothing but 1000 plus 4, 1004. Okay. Okay. Then now next, trace 3. I is equal to 2. 2 is less than 3. Suppose I enter 30 as the answer. Where will 30 be stored? ptr plus I. What is ptr? 1000. 1000 plus 2 into 4. That is equal to 1008. So at address 1008, 30 will be stored. You got it? So this is how the values will be stored. Next, after trace 4, I is equal to 3, 3 is not less than 3, it will come out. So we have a large block of memory, fine, which is stored here, which is allocated, and the values are stored. Finally, how do we print for I is equal to 0, I less than n, I plus plus? Printf %d star. This is called as dereferencing operator. Dereferencing operator, which means ptr plus I. When I was equal to 0, it's 1000 plus 0. It will go to 1000 plus 0, 1000. Since it is star dereferencing, it fetches the value that is stored within address 1000. So output, I'll get 10. Okay, then coming here, next I value is equal to 1. It will come here, 1000 plus 1 into 4, at 1004 value 20 is there. Okay, so it will go fetch the value. Star ptr plus I will fetch the value. Ptr plus I will point the address. Star ptr plus I will point to the address. So 20 will be printed here, 10 and 20, and then finally I is equal to 2, it will go to 1008. What is the value here? It is 30. It will fetch 30 and it will print the outputs. 10, 20, 30 will be displayed. I hope you understood the concept. Thank you.